Hi everybody, let's talk about memory issues. The biggest challenge with a memory issue is tracking down the original source of the memory problem. It's very easy to solve memory problems, but figuring out what is the cause of those is quite difficult. Now previously I've released a series of videos showing different ways to analyze memory issues, but still the real challenge is to figure out how to reproduce the actual problem. So in the latest version of Firefly, as of pretty much today, we've added some new functionality to help. So let's start by looking at our scenario. Our user has been working on the application for an entire day and suddenly get a message of out of memory exception. Okay, we cannot track it to anything specific he's done because he's been working on it all day. Or we're monitoring some kind of server and we can see that one of the processes ran amok, is using way too much memory. So here I have Northwind and I've simulated such a scenario. Let's have a look at the task manager, and you can see that Northwind here is taking 1.2 gigabyte, which represents a huge memory leak. Great. So how do we find what is wrong? What is causing that memory leak? And how can we effectively track it, as our users are obviously non-helpful? They cannot tell me what they've been doing wrong, and what is going on. So for that, in the new version, we've added a few flags. Let's go to the INI, and we'll add an entry called TrackMemory equals Y. And when I run it like that, any error report that gets generated by the program will provide a lot more information about memory. Let's start to look at it. Developer tools, call stack, gives me everything that the normal report includes. And we can see here that on top of the normal information that we're used to, we've got some new information over here. We can see the memory usage. Before garbage collection, it was 5 megabytes. The working set was 43 megabytes. The peak working set was 44. Private memory 31, and virtual memory is 277, and handles is 309. All of this information is gathered and it may be helpful to system personnel when they're investigating a problem. After a garbage collector, the memory went down to 1, and here is again the respective effect on different parameters. So this gives you general information before and after the garbage collection. This section gives us information about the machine. It tells us what is its name, what is its memory load, how much physical memory, how much virtual memory available, and in total. Great. So this gives us a lot more information where we can figure out things that are going wrong. We can actually see the handle count, which is useful sometimes, or stuff like that. But again, how do we figure out the root cause of the problem? Well, after we've set the track memory flag to yes, okay, we can have the user run the application for a while, and when we see that it has a lot of memory, we can then query this screen again and get more information. Let's try to explain the normal cause of a memory leak. Normal cause of a memory leak. Okay, a controller, okay, previously a task or program in Magic, okay, is allocated in memory and is not released due to some bug in our code or your code. Doesn't really matter right now. Okay, so we want to track these controllers and see the ones that are not released. A good memory leak a bug report would include a set of steps that, if repeated, okay, cause a constant climb in memory consumption. Okay, that way we and you can then figure out, yeah, climb. I'm hoping you know what I mean. Constant rise, let's call it. That way my team and your team can then figure out the root cause and solve it. But how could you come up with this set of steps, okay, that if repeated will provide a result? How do you get to that set of steps? Well, after we have set the track memory equals to yes, we can have a user work on the application, and as soon as we see a rise in memory, we can go and have a look at the information that it gathered. So let's go and run the application. Let's say that I've ran this and that. I went to programs, I went to orders, called you a few rows, I printed a report, I went back to orders and I've printed something, and then I went over to customers and products and orders report. I'm simulating a user working all day. Now, the memory tracker that was activated will collect this information and try to find anomalies. So let's go and have a look at the current call stack. We have all the information we already used to, but we have a bit more information over here. We can see a set of controllers that exist multiple times. Okay, we can see the show products exist multiple times, the show customers exist multiple times, the show order details exist multiple times, 3 times, and the winner is show orders totals that exists 8 times. Okay, now, great. So to get this to be a good bug report, we'll close the application, open it again, and now that we know that we need to focus on show order totals, we'll go to show orders, exit, return, look at the stack, and we see that we have 2 instances of show orders and 2 instances of show order totals. Great. Let's run it 10 times. Let's say it was 10. And we can see that the number has risen. 8 instances of show order, 8 instances of totals, and 8 instances of details. So now we have a better idea on the reproduction steps. And this is what we're looking for. When you want to report a bug to us, figure out a set of reproduction steps that when you run multiple times, you will see this information or similar information rising. And we could see that this was because of the show orders, because we can see it here in the call stack, used all around. So we know to pinpoint the process. And if you want to point this even further, we can see here that the totals is actually called in the onEnter row of our show orders. So now I have a theory. If it happens on every enter row, what if I'll enter 10 rows? Will I get 10 instances? So let's have a look. I'll go to program, and now I'll go and iterate, I don't know, 50 rows. So now we can see that we have 83 totals, 9 details, and 8 show orders. Great. So our reproduction is even more focused. We can see here that the leak is actually happening because the totals controller doesn't get cleaned up for a reason that later I'll investigate and figure out the root cause for it. But now I know exactly where to focus on. Okay. So that's pretty much it. This tool effectively replaces all the previous 7 videos that we've done because it gives you the result of what those tools would help you collect. It actually shows it to you and gives you some very detailed information on it. So now when you report a bug, I would want you to use this tool and come up with steps that cause this number to rise on any one of these properties. Also, if the user will get an error message or a crash, this information will get included. Let me demo that. Let's go and run through the memory here. We know now the leak, so we can reproduce it very easily. Just run through memory, and let's see how much Northwing is taking. We are at 350, so we have to do those quite a few more. Here we go, memory is rising, and hopefully eventually I'll crash. And the goal of going this crazy is to eventually see the actual message and show you that that information is also clear there. It will also appear in the profiler if you're using it, and it will also appear in the error file if you have it. So here in the details, we can see the same information. We can see the crash, and we can see that we have 804 instances of totals in memory, which were causing this problem. Great. So now I just have to pinpoint why totals is being saved, and since I wrote this bug, I can find it quite easily. In this case, I'll go to show orders, and I'll go to totals, and I'll remove totals from the YY because here we have a static list that is being collected, which causes the memory leak. So we'll remove these two, we'll remove these, and run the process again. And now when I'll go into orders and iterate a million rows, we can see that it no longer appears on this list, and that means that the memory problem has been solved. I hope you find this useful. Thanks for watching, and let us know what you think.